right. Welcome aboard, everyone. My name is Lieutenant Paul Simas, and I will be your service director for our flight to Mars today. Our flight will take us in enormous altitudes and around Mars and back. We're going to look at our aircraft, and we're going to look at how we're going to land, and all kinds of fun stuff. So sit back, relax, and enjoy the ride. Mars. Mars is a cold desert world. It's half the size of the Earth. Mars is sometimes called the red planet. It's red because of rusty iron in the ground. And we're going to discover why it's like that. So today we're going to look at culture. No other planet has influenced our culture more than Mars. First, explorations. Despite being red, Mars is a cold place, not hot. Robots. Let's take a look at rovers. Mars is the only planet totally inhabited by robots. Exploring Mars. Let's look at the pictures and videos from Mars. Mars is there, waiting to be reached. Buzz Aldrin, the second man on the moon. And that's an iconic picture there of Buzz Aldrin looking at the American flag in 1969. All right, culture. What's the deal with Mars? The god of war. Mars is named for the ancient Roman god of war. The Greeks called the planet Ares. It's pronounced Ares. The Romans and Greeks associated the planet with war because of its color resembles the color of blood. Mars had two small moons. Their names are Phobos and Deimos. They're named for the sons of Ares, the Greek god of war. Phobos means fear, and Deimos means panic. Mars in culture. In the Roman religion, Mars was a very important god. His role was second only to Jupiter, the leader of the pantheon. Mars was the son of the god Jupiter and the goddess Juno. His father, Jupiter, was the god of the sky and thunder. Jupiter considered the chief guardian of Rome. His mother, Juno, was protector of Roman women and the patron goddess of Rome. Both his mother and his father were renowned for strength and protection. Mars himself was the god of war and was himself seen as protector of the Roman army. It was even reported that Mars was the father of Romulus and Remus, the twin brothers who were founders of Rome. Two reasons why Mars is famous today. There was a book published in 1897 called War of the Worlds by H.G. Wells. And then Orson Welles, not related, funny enough, Orson Welles, radio broadcast in 1938, The War of the Worlds. Orson Welles' realistic radio dramatization of Martian invasion of Earth is broadcast on the radio on October 30th, 1938. And what he did, he read the book with such emphasis that people believed that they were actually being invaded by Martians. Fake news. 6 million people heard Orson Welles' broadcast, and of those 6 million, 1 million people believed the Earth was being invaded by Mars. It created panic all across the United States as radio stages Mars raid. They believed that parts of Florida were being invaded, and New York as well, by the Martians. And you can see here in this slide all the news reports coming out. And there's Orson Welles here, if you can see my mouse. There he is reading the radio broadcast and having a little fun with it. I guess you can say that this was the first fake news. So here we have Martians, Bruno Mars, and the Mars bars. Of course, a Mars is a very common name. First explorations of Mars. Let's look at all human explorations. About Mars. Despite being red, Mars is a cold place, not hot. It's full of iron oxide dust, which gives the planet its reddish cast. Like Earth, Mars has seasons, polar ice caps, volcanoes, canyons, and weather. It has a very thin atmosphere of carbon dioxide, nitrogen, and argon. There are signs of ancient floods on Mars, but now water mostly exists in icy dirt and thin clouds. On some Martian hillsides, there's evidence of liquid, salty water in the ground. Scientists want to know if Mars may have had living things in the past. They also want to know if Mars could support life now or in the future. Some data on Mars. Structure and surface. Mars is a terrestrial planet. It's small and rocky. It has a thin atmosphere. It has an active atmosphere, but the surface of the planet is not active. Its volcanoes are dead. This means that the planet is geologically dead. Time on Mars. One day on Mars lasts 24.6 hours. It's just a little longer than a day on Earth. 1 year on Mars is 687 Earth days. It's almost twice as long as 1 year on Earth. Mars' neighbors. Mars has 2 moons. Their names are Phobos and Deimos. Makes sense, right? Mars is the 4th planet from the Sun. That means Earth and Jupiter are Mars' neighboring planets. Quick history. Mars has been known since ancient times because it can be seen without advanced telescopes. Several missions have visited Mars, and Mars is the only planet we have sent rovers to. They drive around Mars taking pictures and measurements. Let's take a look inside Mars. Now, this is a little schematics of the Earth. I could not find one of Mars, but it's very similar inside. It has a core inside, right in the middle of the planet, and this is a big ball of solid iron. A mantle has a mix of rock and iron on its mantle. The molten iron core is now mixed within the mantle, on Earth, as you see in this schematic. Just outside of the solid ball of iron, you have a molten iron core. They rotate inside the planet. This is what makes the planet alive. In the case of Mars, it no longer rotates, and the molten iron core is no longer molten. Is now dusty and is all over the surface and in the mantle. Okay, in the surface, Mars has a rocky surface, very similar to the planet Earth. All right, Paxi is now going to take over. Take over, Paxi.
Hello there, I'm Paxi, an adventurous space explorer, but I don't feel too brave at the moment. My spaceship's galactic navigation system is broken. I'm lost without it. Look, there's a planet up ahead. Maybe there are some people there that I can ask for directions. I hope they're friendly. There's ice at the poles, and I can even see 2 small moons. Where could I be? My spaceship is picking up a signal. Maybe someone's trying to say hello. I'm going to find out. The signal is being sent by this probe. It's the European Space Agency's Mars Express spacecraft. I definitely know where we are now. This is the planet Mars. But I bet you'd already worked that out, hadn't you? Humans have sent more than 40 robotic missions to explore Mars. Soon there'll be more. Some are in orbit, like Mars Express, and some have landed on the surface, like a NASA rover called Curiosity. They've revealed a lot of Mars's secrets. I cannot see any towns or cities. But what a fantastic landscape! This planet is made from rock, like Earth. Earth's surface has lots of colours: green, blue, white, brown. But this planet is mostly shades of red. Luckily, red is my favourite colour, other than green, of course. There are mountains and valleys, and dust being moved by the wind. Let's land and explore. But first, I have to fix my spaceship. That scared me. This is Curiosity, the rover I told you about before. The name really suits her. I'll just reattach this loose wire and my galactic navigation system is fixed. Mars is a close neighbour of the Earth, considering how big the solar system is. It orbits the Sun just like the Earth and the other planets. Did you know that Mars is covered in a layer of rusty dust? That gives the planet its lovely red colour. If you ever visit, you simply must go to Olympus Mons. It's the tallest volcano in the solar system. Nearly 3 times higher than Earth's Mount Everest. Wow! From up here I can see Valles Marineris, a gigantic canyon that would stretch from Spain to Finland. And I can see that Mars has lots of dry riverbeds, where water must have once flowed a long time ago. I can't see any rivers today, only ice in a few places. Do you think that alien creatures have ever lived or are living on Mars? Well, that's another story, which we'll save for another time. So, we've seen that Mars has a rocky surface with really fascinating features. It has mountains and valleys. There are also dry riverbeds. There must have been lots of water here in the past. It even has polar ice caps and 2 small moons. And there are robots exploring Mars.
Okay, rovers. Mars is the only planet inhabited by robots. And here are the rovers that we have at the moment. Sojourner was the first one. Sojourner is a rover that landed on Mars in 1997 in a location called Ayers Vallis, where it explored and took many photos. It was followed by Spirit and Opportunity. They were sent to Mars to find more clues about the history of water there and to see if the red planet could ever have supported life. To do this, scientists sent the 2 rovers to 2 different landing sites. The rovers landed on opposite sides of the planet. The third one was Curiosity. Curiosity is a rover that was sent to Mars to determine if the red planet ever had the proper conditions for microbial life to survive. And the latest, finally, Perseverance. Perseverance is a rover that landed on Mars just a few days ago on February 18th, 2021. It is studying a region of Mars called Jezero Crater. This rover will answer lots of questions about the red planet and search for signs of past microbial life. Exploring Mars. Traffic jams on Mars. Key facts about the Mars rover Perseverance. It was launched on July 30th, 2020 at 7:50 a.m. our time. It landed on February 18th, 2021 at 3:55 p.m. Many of you may have seen it live on TV. The duration of the mission will be at least one Mars year, which is about 687 Earth days, just a little over 2 years for us. And this was done today, so right now it is just motoring along the surface of Mars. Mission: to find signs of life. Studying Mars habitability, seeking signs of past microbial life, collecting and catching samples, and preparing for future human missions. The Perseverance rover has 4 science objectives that support the Mars exploration program's science goals. A. Looking for habitability. Identify past environments capable of supporting microbial life. Seeking biosignatures. Seek signs of possible past microbial life in those habitable environments, particularly in special rocks known to preserve the signs of life over time. Catching samples. Collect core rock and soil samples to store them on the Martian surface. Preparing for humans. Test oxygen production for the Martian atmosphere. So this is how they get there. The cruise stage, this is how the spaceship looks like. Back shell is the parachute and lookup cameras. The descent stage, you see the descent stage and looking down cameras. And the rover, of course, is protected by the heat shield. This is the trajectory once it gets to Mars. The cruise stage separation is about 10 minutes prior to touchdown. And then it goes into heating. It's heating as it comes down on the surface because of the atmosphere. The parachute will deploy at an altitude of 6 to 8 miles at a velocity of 940 miles per hour. The heat shield will leave at an altitude of 4 to 7 miles only at 360 miles per hour. Then the spaceship will look for a radar lock that is looking for a specific location to land. Then it will release the aircraft, power descent, and then the sky crane will lower the rover down to the surface, and then it will fly away. Now let's watch Perseverance land on Mars.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Application indicates.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converged. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. PPA nominal.
We have priming of the landing engines.
Backshell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the backshell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Here in safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver is started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
This is really exciting stuff. Now we'll watch a landing video and a little bit more explanation on what happened.
NASA's Perseverance rover has landed on Mars, and now we get to see video of the landing and hear audio recorded on the surface of Mars for the very first time.
I'm frozen.
After zooming through space for nearly 7 months, Perseverance landed on Mars on February 18th.
Frozen there.
In the final minutes before landing, NASA control showed animations of the rover descending through the Martian atmosphere.
What's that?
It
Oh,
was
now it's
frozen,
working.
Paul.
Now I can see it.
Okay, everyone can see it now?
Yes.
Okay, I'll start over again. Okay.
NASA's Perseverance rover has landed on Mars, and now we get to see video of the landing and hear audio recorded on the surface of Mars for the very first time. After zooming through space for nearly 7 months, Perseverance landed on Mars on February 18th. In the final minutes before landing, NASA control showed animations of the rover descending through the Martian atmosphere, deploying its parachute, and then finally touching down. We even got to see the very first still images taken by Perseverance on the Martian surface. It took some time for video to get beamed back from Mars, but now we've been given a front row seat to see how it all went down, thanks to cameras packed on board. There are actually 23 cameras on board the Perseverance rover. They're designed to do everything from helping with navigation to detecting hazards. There's even a cache cam just to give us a view of rock samples collected from the planet's surface.
But among all that hardware, NASA packed in 6 cameras dedicated to recording full-color video of the entry, descent and landing from every possible angle. There were cameras mounted on the protective back shell of the spacecraft, which gave us a view of the parachute during entry. Then there was a camera mounted on the descent stage looking down onto the rover, as well as a camera on the rover looking back up to the descent stage as they parted ways. Finally, a camera mounted on the bottom of the rover captured footage looking down on Mars as the rover landed. All these cameras showed us the entry, descent and landing in amazing detail, from the spacecraft's heat shield dropping away down to the dust blowing on the surface of Mars as the rover descended, and it was one hell of a ride. NASA calls the 7 minutes it takes to go through the atmosphere and land on Mars the 7 minutes of terror. Why such a terrifying name? Well, that entry, descent and landing is where a lot of things can go wrong. Think of it this way. After taking off, Perseverance was just zooming through the vacuum of space, safe in its protective aeroshell. But to land on Mars, it has to slow down, fast. When Perseverance reached the Martian atmosphere, it was traveling at about 20,000 kilometers or 12,500 miles an hour. When it was about 12 kilometers above the surface of Mars, that's when we got confirmation that Perseverance had deployed its massive 70-foot wide parachute. And thanks to cameras built on the spacecraft, we got to see it happen. Once the parachute started slowing things more rapidly, the heat shield separated, exposing cameras on the rover itself, meaning the rover could see Mars for the first time. And that's when things got really clever. Perseverance's landing site, Jezero Crater, is about 28 miles wide and full of rocky boulders and steep cliffs. NASA couldn't guide the rover from here on Earth. The communication delay would be too long. So the spacecraft used something called terrain relative navigation to capture images of the Martian surface and compare them to maps of Jezero Crater to find the best place to land. In the final seconds before touchdown, when Perseverance was about 20 meters above the surface, it did what's known as the sky crane maneuver, where the rover itself was lowered down from the descent stage on a set of cables, getting its legs and wheels ready to land. And then boom, touchdown. Perseverance had landed. The rover had one more surprise in store. Before launch, NASA installed a microphone on Perseverance to capture the sounds of the mission. Sadly, a communication error meant we didn't get any audio of the landing itself, but NASA did manage to capture audio on the surface of the red planet after the rover had landed. You can hear the sound of the rover whirring away, and then in the background, the sound of Martian winds. When NASA tuned out the sounds of the rover, you can hear those winds perfectly. The first sounds recorded on Mars. And the good news is, there's still more footage to come. If everything goes to plan, we'll see images of Perseverance roving around on Mars, surveying the red planet and collecting its rock samples as it searches for signs of ancient life. And then we'll hopefully see another big first, the launch of the Ingenuity helicopter, Perseverance's very own autonomous drone, and the first spacecraft humans will ever fly on another world. There is so much more to get out of this mission, and back here on Earth, we all have a front row seat. If you're just as excited as we are about this whole rover mission, drop a rocket emoji in the comments below. And remember to stay tuned to CNET. We'll have plenty more space news for you, including that very exciting Ingenuity helicopter flight coming soon.
2026, here we come.
Yes, that will be the next power flight to Mars, which we all have our names registered and we'll go on the next rocket. On this presentation, we
Seriously,
view...
just kidding.
Pardon? What's that?
You're kidding, right?
No, you
Serious.
signed up. You signed up on
My
the
name's going to be on Mars.
Mars?
Yeah, your name's going to Mars. Yeah.
We're going to have to wait 6 years for our names to be on Mars.
That's right.
That's a long time.
Guys,
No, it's a
not that
beautiful
long.
time.
5, I think. 5 years.
5 years.
I'm
Correct.
patient. I can wait that long.
Wait
Just
a
to have
minute.
some
Are we
knowledge
going
to see my
on
name
top
on
of that
Mars.
rocket, inside the rocket, landing on Mars, walking on Mars, jumping on Mars, flying on Mars? Are we
That's
doing
right.
all that?
And we'll be doing all that. You'll be able to check in to see what is going on once we're there.
I thought that the computer would somehow leave no gravity in it so I could start flying.
So let me finish
Okay.
this presentation. Okay, on this presentation, we viewed a history of Mars. We viewed its geology and impact on human culture. The rovers, we viewed the rovers currently on Mars. The European Union, China, and other countries have sent research probes to Mars as well. And then we viewed the descent, and we watched together Perseverance land on Mars. So thank you for flying with us. And now we can entertain any questions you may have. Any questions? No questions.
Yeah,
Okay.
Rachel wants to go
Truman has questions too.
She
One at a
wants-
time, guys.
right now.
He wants to go right now. Yes.
Go ahead,
Right
Truman.
now would be tough.
Hold on, what was my question? Never mind, I forgot.
Okay.
And
No worries.
And you remember, come back.
All right.
So one of the things I will tell you that was not in the presentation is that what they suspect happened to Mars, remember the core is a big ball of iron. Sometime in Mars' ancient past, another object crashed into Mars, an object about the size of our moon, crashed into Mars and it deformed, it destroyed essentially the planet. Most of that iron core was destroyed, and then what happened was it created a cloud of dust, and for a while Mars actually had rings. Eventually the ring was all iron. Eventually the iron fell back on the surface of Mars where the oxygen rusted the iron, and this is why Mars has a red surface today. Now, why is Mars a geologically dead planet? Because inside the Earth, for example, this iron core moves, it rotates inside the Earth around a molten mantle of hot molten iron. So when iron rubs with another iron, what happens? You got electricity.
When iron rubs other iron, it provides friction, which provides heat.
Heat and electricity, thus creating what we desperately need, which is the magnetic field around the planet Earth. So the magnetic field protects us from solar radiation. Now, without an active geologic surface, Mars is a dead planet. The magnetic field is now distributed all over Mars. They have little short magnetic fields all over the place. So it's not particularly safe from solar radiation at the moment. So scientists are studying what happens. So without the solar radiation, Mars's oceans have evaporated. Now, some scientists theorize that the oceans have end up on Earth as dispersed into space and eventually showered on Earth, and we have Martian water right on our planet right now. As we do have Martian rocks, we do get Martian rocks every now and then. And so that's essentially what they think may have happened to Mars. They discovered some water in Mars not very long ago. About 20 to 30 years ago is when they discovered the signs of water, salt water. And if you have water, then there's a possibility that you could have life. Now, there's no bones or skeletons or any signs of civilization, so it doesn't look like Mars had any sort of animal life or plant life. But it is possible that Mars could have had microbial life, meaning bacteria, viruses, and things like that. Not disease-making, but alive anyway. And so that's what the rovers are trying to figure out, if they did. And if they did, could they have showered the Earth with those microbes and eventually seeded life here? Yes.
Thank you.
Okay. Do you guys have any questions? Truman, you have a question?
Do you think Mars ever had rain before?
Mars did have rain before because it had oceans and it had an atmosphere that was nice and thick. So it was very, very similar to Earth.
Do you think it was that similar to Earth when Earth was in its, molten lava stage?
Say that again?
Never mind.
I just didn't understand the question. That's all.
Yeah.
What did you say?
I was just wondering if you thought Mars was habitable at the time Earth wasn't.
They evolved at the same time. Mars was the entire solar system was formed about 4.5 billion years ago when the sun was born. So the sun, all the planets are about. The sun is older because the sun started first. Then a cloud of dust rotated around the sun. Eventually, the planets that are closer to the sun had enough gravity to become solid rock planets. So the first four planets, Mercury, Venus, Earth, and Mars, are rock planets. Then the gravity is not strong enough to make the planets solid. So they're just balls of gas and dust, and they're enormous, like Jupiter and Saturn. They're very big. Jupiter is very hot, essentially. They say that Jupiter is a failed star because it has a massive gravity, but not enough to become a rock planet. If it became a rock planet, it would be extraordinarily hot, and then it could become a star itself. It has such gravity that it holds together the solar system. They say that Jupiter is essential to our solar system integrity because it maintains the rocky planets close to the sun and the gaseous planets on orbit. Now, we did lose one planet. I mean, he's still there, but we demoted the planet Pluto, and now it's a planetoid.
Isn't it a dwarf?
Because there are other objects around the same area that have the same characteristics and are about the same size. So Pluto is now just a planetoid around the outer rims of the planet of the solar system. So easy to remember, those planets that are closer to the sun are rocky planets. The ones that are further away from the sun are gaseous planets. Now, there's only two planets that live in an area called the Goldilocks zone. This area is the area where water can exist in liquid form. Why is that important? Because with liquid form, you can have life. So the only planets that could have happened that is the Earth, of course, and Mars. Those are the only two. Mercury is too close to the sun and is incredibly hot. Venus, it rains sulfuric acid, so no life can survive there. Is just a molten ball of lava. The Earth is perfect, and Mars could have been a twin of the Earth, just a little bit smaller. It's about the size of Africa in diameter, so it's a little bit smaller than the Earth. And but it could have been just like it. So what the scientists want to do now is they want to see if they can revive Mars, not to live there, but to explore. So if they can create enough oxygen with the current water that exists in Mars, then maybe they can do all kinds of exploration. There are other planets in the solar system, although the gaseous planets don't have a solid surface. Their moons do. Right now, there is a moon called Europa, and I believe is one of the moons of Saturn that has a solid ice surface. And they believe that under that surface, they have an enormous ocean of salt water, which could possibly have life, like fish and stuff. Jago, you have a question.
Yes. Why do other planets' moons have like an actual name, but our planet moon is just called Moon?
That is an excellent question. No, I don't know the answer to that. What I can tell you is that most of the planets' names and moon names are names taken from Roman and Greek mythology. So, for example, Mars is the Roman god of war. Jupiter is its father, right? Venus is the goddess of beauty, and so on. So normally they take even the moons of Mars, Deimos and Phobos, are also the children of Mars. So you can see that they take the name of Roman and Greek mythology and place it on Mars. But it is possible if you discover a new object in the sky that could be named after you. Many people have discovered new objects, comets and things like that, and they inform the authorities and NASA and so on, and they get named after themselves. So that's pretty interesting there. So you could have a Dago star going around.
Yeah, or imagine that, Jago. You'll have a planet Jack Jago.
That's right.